Hi everyone, I'm going to do another integral here. It's going to be the integral of the square root of 1 minus 25x squared dx. And so when you look at an integral like this, you really don't know where to start. Anytime you see a square root, there's a good chance that you might have to use trigonometric substitution. To do that, it's actually not too difficult. So trigonometric, we're going to actually literally draw a triangle. Okay, and see, the reason I'm drawing a triangle is because you've obviously probably by this point know Pythagoras theorem: a squared plus b squared is equal to c squared. And so a squared plus b squared is equal to c squared. So this kind of looks like Pythagoras theorem. This kind of, like, to kind of get it into this form, it would look like b squared is equal to c squared minus a squared. And you see it? And then if you square root it, you see you can get b is equal to, this would be your c, and this would be your a. And so if you're going to do that, now what you can do is literally make this thing one of your sides of your triangle. So your 1 is definitely going to be your hypotenuse. 1 squared. You can, or 1, sorry. 1 will be your hypotenuse. This one, you can make this 25x squared into a square by just factoring. You can make this a 5. 5 squared is 25. 5x. And if you square it, you're going to get 25x. So this is your other side. It's not your hypotenuse. So now you just have to pick correctly. You got to pick the side that's going to help you. You want this one over the 1. You want to pick this so that it's on top of the fraction, not on bottom, to make your life a lot easier. So the only way to do that is if we pick sine. Sine is opposite over hypotenuse, right? So if you pick sine, so then you can make this one a 5x, and this side will be the entire function. This bottom side will be 1 minus 25x squared, right? So if you make, then you can just say sine of x is equal to opposite 5x over hypotenuse, which is 1. And you can actually solve for x here, and you just divide by 5, and you divide by 5, so 1 over 5 sine of x is equal to x. So now you have this, you have an x here, you can actually put this into here, but if we're going to do that, we'll also have to find out what dx is as well. Sorry, we should actually say sine of theta. This is your angle theta, not sine of x, because now that you've made it into the form of theta, you have theta, you can't have theta and dx, right? So you got to find out what dx is. It's pretty easy. You can just take a derivative. So this would be dx is equal to 1 over 5 sine, the derivative of sine x is cos x, right? So that's your derivative right there. So anywhere you see the dx, you're going to pop this into there. So anyway, so now that you have that, you would just go the square root of 1 minus 25 times x is 1 over 5 sine theta squared. And dx is, we can multiply times 1 over 5 cosine theta. I don't know why I keep writing x, it's cosine theta. Anyway, so now that you've got into this one, you can actually simplify it. 1 minus, if you square this, right, you're going to get 1 over 25, right? And the 25 will cancel out with the 25 in the bottom of this fraction. So you're just going to actually be left with 1 over sine squared x, or theta, sorry, sine squared theta, multiplied by 1 over 5 cosine theta. Now, you should be familiar at this point in your integral calculus what this is. This is a trigonometric identity, which 1 minus sine squared is cosine squared. So it's just the integral of cosine squared theta times 1 over 5 cosine theta. And if you take a square root of that, you're going to be left with cosine theta times 1 over 5 cosine theta. You can bring the 1 over 5 up front. 1 over 5 integral cosine squared theta. Right? What is the integral now of cosine squared theta? Yeah, so d theta. Sorry, this should also be having d theta. D theta, d theta, d theta. Okay. Now, how do you integrate cosine squared? Well, there's another identity that you got to know. You got to know that cosine squared is actually 1 over 2 times cosine of 2 theta plus 1, don't forget the plus 1, d theta, right? So now you can actually multiply the 1/2 times the 1/5, so you get 1 over 10 integral of cosine 2 theta plus 1 d theta. And that's basically, now that you know what this is, you can actually just go ahead and integrate straight through. So it will just be 1 over 10 times, you could actually do a u substitution here. So you can actually, so the integral of cosine 2 theta, you can say d theta, you can say let u equal 2 theta, right? So du is going to be just 2 d theta, and then 1/2 du is going to be d theta, right? So now that you have that, you can actually put that into here. Okay, I'll get another piece of paper here. Right? So the integral of cosine 2 theta d theta is basically, you found out that the d theta is 1/2, so you 1/2, and don't forget that 1/10 that's still remaining here. Cosine of u du. So now you have, this is pretty easy. You should know what the integral of cosine of u is. So this is 1 over 20. The derivative of cosine, the integral of cosine is sine. It would be sine u, right? But sine, the u, we said is going to be 2 theta, right? So it will just be 1 over 20 sine of 2 theta. That's the integral. So now you've integrated this out, but don't forget that we still have the 1. So it's the integral of 1 d theta. So the integral of 1 is just theta, right? So you have this plus theta. So we've actually pretty much done, we're almost there, but we started off with x. You can't finish your answer, leave your answer in terms of theta. So you got to switch it. You got to go find out what is theta equal to, and sine of 2 theta too. So remember, like, going back to that triangle that we had, theta, and we said this side was 1, this side was 5x, and this side is going to be 1 minus 25x squared, right? So to find theta, we said sine theta is equal to 5x. To find theta, you just take an inverse curve. So theta is equal to arc sine of 5x. That's what theta is equal to. So we found this one. Now we got to know what is sine of 2 theta. Now you got to know the other identity. Sine of 2 theta. Sine of 2 theta is equal to 2 sine theta cosine theta. You got to remember that identity. So now you can actually substitute that in 1 over 20 times sine, now you have 2 here, so it'll be 2 over 20, so you'll just become 1 over 10. 1 over 10 sine theta cosine theta plus, you said the theta was arc sine of 5x. Now, we already found out what sine theta was. It's equal to 5x. We have 1 over 10 times 5x. Now we gotta find out what cosine theta is. Cosine is so adjacent over hypotenuse. So here's your adjacent. So your adjacent is 1 minus 25x squared, right? Over your hypotenuse, which is 1. So we have everything now. So sine of theta is 5x, and this one is multiplied by 1 minus 25x squared, right? Plus arc sine of 5x, and that's your answer. I kind of went through it pretty fast here because I kind of know what I'm doing, but I might have made mistakes. If you find any mistakes, please let me know. But yeah, so we started off with the integral of the square root of 1 minus 25x squared. If you don't know what's going on, immediately try and look at the square root and say square root of 1 minus something. That should remind you of Pythagoras' theorem. A squared plus b squared is equal to c squared. And you just have to figure out, you draw a triangle. First, right away, draw a triangle. Make this angle theta. And then try and figure out where can I put this so that it will give me something over something where my the x is going to be on the top so that I can easily integrate it. And in this case, sine theta is what works. Let's just say sine theta. Anyway, so once you do that, you find out what sine theta is. You take a derivative to get rid of all the x's. You substitute your x's with the sine of theta in this case, and then you just basically work through it. For these, you really have to remember your identities. They're really key. If you're lucky, your teacher might give you the identities. If you're not, you might have to memorize them, but it is what it is. But yeah, that's basically how you do it. If you still don't understand, I'll leave my email address at the bottom of this, and you can just email me or tweet me. My Twitter is linked there. But yeah, I hope this helped. Have a good one.